The question here says, Shane is studying the lengths of the tails of male red kangaroos. He makes a random sample of 14 male red kangaroos and measures the length of the tail, x meters, for each kangaroo. He then calculates a 90% confidence interval for the population mean tail length, mu meters, of male red kangaroos. And he assumes that the tail lengths are normally distributed and finds that the mean has interval 1.11 to 1.14. So find the values of sum of x and sum of squares in x. All right, so basically here we know that this value 1.11 is calculated mean, which is sum of x over n. In this case, n is 14, minus the critical t value. All right, so we need to know what the critical t value is. Let me bring this down a little. So let's just start by writing that the critical t value at, since n is 14, the degrees of freedom will be n minus 1, so that's 13, and it's a 90% confidence interval, which means we are working with the p-value of 0.95. So basically, that's what we have. So we go to the tables, all right, and we go to 13, and that's 13 under 0.95. So we have this value here, 1.771. So 1.771 is the t value. Okay, so that's 1.771, and that's of s over root of 14. We call this equation 1. Then we also have 1.14, which is the upper. It's x bar, which is sum of x over 14, plus, now this is 1.771 of s over root 14. That's equation 2. So we can actually add the two equations, right? So equation 1 plus equation 2 would give us, if we add here 1.11 and 1.14, we get 2.25. So we have 2.25 being equal to, now we add this and this, where we get 2 of sum of x over 14, which is like sum of x over 7. So therefore, sum of x is equal to 7 times 2.25, and 7 times 2.25 gives us 15.75. So we have 15.75. So this here is the answer for sum of x. Okay, that's what they want us to find. That's one of the things they want us to find. Next is finding the sum of squares of x, right? So we are going to take any one of the equations, right? I will take equation 2, okay? So we have equation 2 here, and it's 1.14 being equal to the sum of x over 14. The sum of x, we've now found it to be 15.75 over 14 plus 1.771 of s over root 14. Right, so we can actually find s, making s the subject here, and we can do that by saying 1.14 minus 15.75 over 14, and we multiply that by root 14 over 1.771. So I've just made s the subject, right? And when we do that, let's see what we will get. All right, this gives us 0.031691. All right, so 0.031691. Okay, so that's the value we're getting for s. And we know that s is calculated. Okay, we know that s squared is actually 1 over n minus 1 of the sum of squares minus the sum of x squared over n, right? So that's what we're going to use right here. Let me just put it on the side. Okay, so basically we're saying s squared, which is now 0.031691 squared, is equal to 1 over 13 of the sum of squares, and that's minus the sum of x squared, which is 15.75 squared over n, which is 14, like this. So we can make the sum of squares the subject. That's going to be equal to 0.03169 squared times 13, right? And that's going to be plus. Okay, we're going to remove this because we no longer need it. So that's going to be plus 15.75 squared over 14. All right, so this is going to give us, now we do the calculation, and this gives us 17.7 to 3SF. So the sum of squares in x is 17.7. And this again is the answer. That's also what they wanted. All right, so that's how we do it for this particular question, where they wanted us to find the sum of x and sum of squares of x. And that's how we do it.